Have you ever wondered why Google doesn't show too many search results on a page? In this video, I step into the role of a product analyst at Google to analyze how the number of search results affects their user interaction times. And I use Python for this and real analytics techniques. Hello, if you're new here, welcome to Emmy the Analyst channel. Kindly subscribe to my channel if you haven't. Check out my previous videos. So this is a Python summer party challenge, and this is day 4. So you're welcome. So day 4 we're looking at. So day 4 we're working with Google, investigating user interaction engagement with search results pages. So let's delve right in. Hello, welcome to day 4 of our Python summer tutorials. So I have my data set here already imported. So what I will do, I have the user ID, the dates of interaction, the time, then the search results displayed. Then I have null for nothing. So the first thing I want to do is to run this code. Okay, it's giving me error of none, like name lord is not defined. So I'm going to need to replace this null with 0. Okay, let's run again. Okay, code executed. That's good. So let me print out my table so I'm sure I have it. So when I run this, good. This is to confirm that the table is already printed. So based on the question we have here, question 1 says identify and remove any duplicate entries in the data set to ensure data quality. How many duplicates were found and removed? Okay. So the first step I'm going to do is to check for the number of duplicate rows. Yes, I want to check. Now, how do I do that? I would give a variable called duplicates. Let's go count. So my table there's a function called duplicated. So it counts for me duplicates. So I'm going to sum it. So let me print out my duplicates counts. So I have two duplicates as seen here. So how do I remove them? So I'm going to remove duplicates. So I will call this user engagement data cleaned. Call it cleaned. Then my data itself. Then I'll drop. There's a function called drop duplicates. Yes, that's it. Drop duplicates. So it's a function. It makes it easy for us. So the next thing I want to do is just to print out this. Good. Duplicate is gone. Duplicate is gone. Now, how would I know that? I'm just going to add some text to this, make it more explanatory. So the number of duplicates found and removed is now okay, I can use this. Yeah, I can use this. Duplicates counts. So I'll put F at the beginning. So let's run this and see. So number of duplicates found and removed is 2. Okay. So I think we're done with this. So how many duplicates were found and removed? Identify and remove any duplicate entries in data set to ensure data quality. This returns the whole data, but they want us to know how many was removed. So I will use a function called shape. I think that's shape. Yeah, correct. Yeah. Let's check this out. Okay, so 4 columns, 58 rows. Now let's see just before I cleaned it. So I'll remove this. Okay, so I expect 2 figures here. So there were 60 rows before, 4 columns. Now there are 58 rows, 4 columns, because 2 columns was removed. So I can just add a text here. To make it more so this helps me to understand better what I'm working with. Shape after removal of duplicates and add those stuff here. Now let's run this. Good. So we're done with question 1. So question 2, it says after dropping duplicates, aggregate the data to find the average user interaction time for each number of search results displayed per page. What are the average interaction times? So I'll be working with the cleaned data here. I'm working with the cleaned data here. So I want to group by search results. To group by search results and get out the average interaction time. So let's get average interaction time. Now I'm going to assess the user cleaned data and group it by, remember we have the group by function. So what am I grouping by? Group by search. There's a column called search. Let me check for the correct spelling. The search results displayed. I'll just copy it to make it faster for me. Search results displayed. As index function. So index is equal to false. That is false. So I'll give it a name, interaction time. I'll put the name of the column. Now I want the mean of that. This is the average. So I think we're done with this. So let's, okay, there's an error here. Let's check where the error is coming from. Okay, I think the error is from here. The error is from the naming. Okay, so the next thing I want to do to print out let's have the average. Let's print out what we have there already to have an idea. Okay, we have an idea of search results displayed 5, 10, 15, 20, and these are the average interaction time, like you can see. But the question is said, after dropping duplicate, aggregate data to find the average user interaction time for each number of search results displayed per page. What are the average interaction times? For each number of search results, and we have that here. Yes, we can actually stop here, but one thing I'd like to do is to rename this heading, the column name, to show average interaction time. Okay, one of the best way I can do that now is okay, let's do like this, interaction times. Okay, let's say function called rename column. Remember, Python is very case sensitive. Then I'll call it average time. Is true. Okay, so this works. So I'm gonna copy this down. So let's check it out. I was given an error. This should be like this. Okay, now we'll get it done. It's done. So question 2 is done. Now question 3. We said sort the aggregated results from question 2 to determine which number of results, search results per page, has the highest average user interaction time. What is the optimal number of search results per page? So this is more like a continuation of the page question 2. So the first thing I want to do is to sort, and I'll sort it descending order. I'll sort the interaction time, the average interaction time descending order. Okay, so I just sorted average times is equal to remember, it's a function called sort value. Okay, we're sorting by. The by is the first thing. So the column name average interaction times. Sorting by. So and I ascending false, because we are doing descending. So ascending has to be false. So this is done. So let's print out this and see. Okay, now we have from the highest to the lowest. So we've been able to sort search results per page from the highest average user interaction time. And the next question here is what is the optimal number of search results per page? Optimal number of search results per page. So let's go. I'm going to show you how to identify So I'll call this optimal results is equal to, I'm working with the sorted average. There's a function called ilog. And what ilog does, okay, now, so this optimized results here. So I'm getting the first row from the sorted array table. So I want to print out that. Let me print out so you can see optimal. So it's returned the first optimal result. Optimal result, that's 70.6875, and search result displayed is 10. So I can add some extra text here just to make it more explanatory. I'll do that now. Something like okay. Good. So this is the end. That's the end of day 4. So that's the end of day 4. I was able to load my data. Question 1, remove duplicates. Found out how many duplicates was removed. Question 2, I got the number of average interaction time per search results. then here I sorted it by descending order and got the optimal results. So that's the end of this class. Thank you.